Lesson 12.3. Analyze geometric sequences in series. A geometric sequence is created by multiplying each number by a common ratio, which we'll call R. So the last one, the arithmetic sequences, we added the common difference. This time we're multiplying by the common ratio. So we look here and we decide, what's that multiplying? That's times 2. This is times 3. That's times 4. Are those the same? No, those are different. So no, it's not a geometric sequence. How about this one? Boy, I don't know what I'm multiplying by. So I can take one of the numbers, say the 27, and divide it by its previous number, the 81. And we reduce. If we reduce by, say, 9, that'd be 3 over 9. Oh, wait, that is 1 over 3. Then I take the next two numbers, the 9 and the 27. 9 over 27, reduce those by 9, gives me 1/3. And then I take the 3 over 9, which is 1/3. And then the 1 over the 3 is 1/3. So it's always multiplying by a third. Therefore, yes, it's geometric, and R is 1/3. The formula for the nth term is an equals a1 times r raised to the n minus 1. If you care how we get that, let's say we have the series 1, 2, 4, 8, 16. So I'm multiplying by 2. So I multiply by 2, multiply by 2, multiply by 2. So my first term here n is 1, 2, 3, 4, 5. So when n is 1, it is just an, or a1. When n is 2, it's a1 times 2. So that was when n is 2. When n is 3, for the 4, that's a1 times 2 times 2. But that was the 3. Notice the exponents are 1 less than the n. The first one would be a1 times 2 to the 0. So the exponents are 1 less, hence the exponent is n minus 1. So let's write a rule for the nth term and find a8 out of 5, 2, 0.8, 0.32. Oh, first of all, you have to find the r. So if I take my 2 and divide it by my 5 and reduce that, it appears to be 2/5. Or I'm multiplying by 0.4, however you want to think about it. So I know my r is 2/5. My a1 is obviously 5. So fill it into the formula. An equals a1 r to the n minus 1. Now to find a8, I simply put an 8 in for the n. So I put an 8 in for the n, run it through my calculator. That is a8. All right, one term of geometric sequence is a4 equals 3 and r equals 3. I'll write a rule for the nth term. Well, if I start off with my formula, an equals a1 r raised to the n minus 1. I know when n is 4, the an is 3, so I can fill those in. I put the 3 for the an, 3 for the r, and a 4 for the n. Of course, 4 minus 1 is 3. 3 cubed is 27, so that part comes 27. Divide by the 27, and a1 is 1/9. So now we can write our rule. We know the a1, we know our r, fill it in. 1/9, 3 to the n minus 1. If two terms of a geometric sequence are a2 equals -4 and a6 equals -1024, write a rule for the nth term. Well, I have 2 points here. N is 2, an is -4, so I can fill those in. AN's negative 4, the N is 2. And then I have my other point where N is 6 and AN is negative 1024, so I can fill that in. After I simplify this first one, 2 minus 1 is 1. So I fill in my second point and simplify. 6 minus 1 is 5. And now I have two equations with two variables I need to solve. I cannot use elimination because they are not linear. So that means we need to use substitution. So I'm going to take my first equation and solve it for A1. I'll do that by dividing by R. So I took this first equation, divided it by R. Plug that into the second equation. So I took my second equation here. Only A1 was that one. To multiply a fraction with a non-fraction, I'm going to put it over 1. And multiply across. So I'll have negative 4r to the 5th over r times 1. R to the 5th divided by r, oh wait, that'd be r to the 1st, subtract exponents, you end up with r to the 4th, so negative 4r to the 4th. Divide by the negative 4, and we'll have to take a 4th root. So we get 4 for our r, technically it could also be negative 4. Did that by taking a 4th root. So now we know A1. Oh, we don't know. Yeah, we don't know A1. We had to find A1. So take that and plug it back into there. A1 was negative 4 over r. R was 4, so A1 is negative 1. And then we have our answer. AN equals A1 r to the n minus 1.